Miss YY channel. Today we are going to discuss chapter 2.2 Relative Atomic Mass and Molecular Mass. So the learning outcome for today, in your syllabus we will only cover on the definition of the relative atomic mass and relative molecular mass based on the carbon-12. Relative atomic mass represent the ratio or the comparison of how heavy an atom of an element as compared to an atom of another element. And initially, hydrogen is used as a standard to compare the relative atomic mass. So if I want to find the relative atomic mass of carbon, so it means that I'm comparing the weight of one carbon with the weight of one hydrogen atom. So as we know, the atomic mass of hydrogen is 1 unit and the atomic mass of carbon is 12 unit. So the relative atomic mass of carbon is equal to 12, which means that carbon is 12 times heavier than hydrogen atom. So it means that relative atomic mass is telling us the ratio of the weight of carbon to one hydrogen atom, which is 12 times heavier. And after that, hydrogen atoms was found not very suitable to use as a standard because it is too light. So the oxygen atom as a standard in relative atomic mass was introduced, but further on, scientists think oxygen is also not suitable because there are 3 oxygen isotopes in the Earth. So eventually in 1961, carbon-12 is used as the new standard to find the relative atomic mass. Because carbon-12 can exist in many substances, which is, it can be found, carbon-12 is abundant in the nature, and then it can also be easily identified in the mass spectrometer, and carbon can exist as solid at the room temperature and pressure. Relative atomic mass, the symbol given is AR. And relative atomic mass can be defined as average mass of one atom of an element as compared to 1/12 mass of one atom of carbon-12. So this is a formula given how we can calculate the relative atomic mass. So the average mass over 1/12 of the mass of one carbon-12. So normally we always use average mass because most of the atoms that occur naturally in the air can have 2 or more isotopes. And remember, relative atomic mass is a ratio of the mass of one atom compared to one carbon-12, so it has no units. Okay, so let's look at the example of how to find the relative atomic mass of chlorine atom. So as we know, there are 2 types of chlorine isotopes that occur naturally on Earth, which are chlorine 35 and chlorine 37. So to find the relative atomic mass, first thing is we have to find the average mass of chlorine atom. So the average atomic mass formula is a total it's a sum of the abundance multiplied by the isotopic mass over the total abundance. So abundance refers to the amount, or sometimes the question will give you in terms of percentage abundance. So here we can see the abundance of chlorine 37 is we have 2 chlorine 37 atoms, and chlorine 35 the abundance is 3, which so we can write the formula of 2 times 37 AMU, which is the isotopic mass, plus 3 times 35 AMU, which is the isotopic mass of chlorine 35, and divide by the total abundance, which is 5. So the average atomic mass of atoms, the unit is always given in AMU, because the mu is like a unit to represent the mass of an atom. So just like other unit for the mass, we have is kilogram, gram, and ton. Okay, so this is a unit of mass, and because the mass of atom is very small, so we cannot use kilogram or gram. So the unit to represent the mass of atom is AMU. So you will get 179 mu divided by 5. We can say that the average atomic mass of one chlorine atom is 35.8 AMU. So next one, after we got the average atomic mass of chlorine atoms, so we use the relative atomic mass formula, which is the average mass of one chlorine atom over 1/12 of the mass of one carbon 12 atom. So the average atomic mass of one chlorine atom is 35.8 mu over 1/12 times 12 AMU. So the carbon 12, the mass is 12 AMU. So 1/12 we can cancel off with the 12, so it's equal to 1, and based on the equation we can also cancel the AMU. So the relative atomic mass of chlorine is 35.8. So remember, for relative atomic mass there's no unit. So what does the information tell us? So based on the relative atomic mass, we know that chlorine atom is 35.8 times heavier than one carbon 12. So next we are looking at relative molecular mass. So the symbol given is Mr. So relative molecular mass can be defined as the average mass of one molecule of the substance as compared to 1/12 the mass of one atoms of carbon 12. So this is almost similar to the relative atomic mass. So relative molecular mass is also the ratio, but now we are comparing the mass of one molecule to the 1/12 of mass of one carbon 12. So relative molecular mass, normally we can calculate by taking the sum of the relative atomic mass of all atoms shown in the molecule. So means that to find the average mass of one molecule, we need to take the sum of all the relative atomic mass of the atom. Okay, so if the question is looking for the relative molecular mass of one H2O molecule, so it can be defined as the average mass of one H2O molecule as compared to 1/12 times the mass of one atom of carbon 12. So in other words, we are trying to find the ratio of how heavy one H2O molecule as compared to one carbon 12. So if the average mass of one H2O molecule is 18.515 mu, so the relative molecular mass of H2O will be equal to 18.5 mu over 1/12 times 12 AMU. So we can cancel off 1/12 and 12, and we can also cancel off AMU on the top and bottom. So the relative molecular mass of H2O is equal to 18.15. So you can also see the value where average mass, we have the unit mu, but for relative molecular mass, there's no unit because it is a ratio. So the value are similar, but one is with unit and relative molecular mass is without unit. Similar to relative atomic mass. So atomic mass, average atoms we have unit, and relative atomic mass there's no unit. So based on this information, we can say one H2O molecule is 18.15 times heavier than one carbon 12 atom. At the end of the session, you need to know how to define and write the formula for relative atomic mass and relative molecular mass. So both of them, the definition is quite similar, but relative atomic mass, we are comparing the ratio or how heavy is one atom as compared to one carbon-12 atom. But for relative molecular mass, we are comparing of how heavy is one molecule as compared to one carbon-12 atom. So remember, for both relative atomic mass and relative molecular mass, there is no unit. If you like my videos, please click like, share and subscribe to Miss YY channel. Thank you.